Quadratic equations. One of the most difficult but still interesting chapters if you know what the concept is. Let's get started with it so that we could avoid any confusions and possibly get this corrected. So, chapter 4 Quadratic equations. I shall do the videos of the other chapters later on. You can also put that on the comments below so that I can be notified on which chapter that you want the video of. Okay, let's get started. 4.1 Introduction. In chapter 2, you have studied different types of polynomials. One type was the quadratic polynomial of the form ax square plus bx plus c, where a not equal to 0. Okay, this point is important, this one. A is not equal to 0, and here's the general form. When we equate this polynomial to 0, we get a quadratic equation. So a quadratic equation comes up when we deal with many real life situations. Okay, so for instance, suppose a charity trust decides to build a prayer hall having a carpet area of 300 square meters. Okay, that's with its length, okay, 1 meter more than twice its breadth. 1 meter, so let's say that the breadth is x. Okay, then according to this statement, that is 1 more than twice its breadth, the length will be 2x plus 1. That is what is shown here. Okay, what should be the length and breadth of the hall? Now suppose the breadth of this hall is x meters, just like this situation. Its length should be 2x plus 1 meters, just like this. We can depict this information pictorially as in figure 4.1. Just check this. Now the area of the hall according to the area of a rectangle is length into breadth, that is 2x plus 1 multiplied by x. Always remember to put 2x plus 1 in a bracket because this is a unit. Okay, this is a unit. What do I mean? If you get 2x plus 1 multiplied by x, then that will be equal to 2x plus x. Okay, but since 2x plus 1 is a unit, that is something together, not broken up, the part of the same thing basically. 2x plus 1, you put that in bracket and x. Now using the distributive property, we can distribute x over both of these. Okay, and you will get 2x square plus x. Now what is this? This is 300. So this matches what is given here. Now to make it in the general form of ax square plus bx plus c equal to 0, just take the 300 to the other side. So 2x square plus x minus 300 equal to 0. Pretty easy thing. Alright, let's continue. So the breadth of the hall should satisfy the equation 2x square plus x minus 300 is equal to 0, which is a quadratic equation. Now what do I mean, or what do the textbook mean by satisfy the equation? See, there's a value of x. Okay, there's a value of x, and when I put this value of x in this equation, then 2x square plus x minus 300 will be equal to 0, and we are supposed to find what that value is. So I think the answer is like 12.5. So we'll check how to do this later on in this chapter, but we will definitely see how to do this. So many people believe that Babylonians were the first to solve quadratic equations. For instance, they knew how to find two positive numbers with a given positive sum and a given positive product. And this problem is equivalent to solving a quadratic equation of the form x square minus px plus q is equal to 0. Okay, basically this one. Greek mathematician Euclid developed a geometrical approach for finding out the lengths, which in our present day terminology are solutions to the quadratic equations. finding out the lengths. Okay, solving of quadratic equations is in general form is often credited to ancient Indian mathematicians. In fact, Brahmagupta, that is from c 598 to 665, gave an explicit formula to solve a quadratic equation of the form ax square plus bx is equal to c. So later, Siddharacharya, CE 1025, derived a formula now known as the quadratic formula. Now, a few things to note here: such questions like these, or where such scientists lived, will not be asked on the board exams, but are very important for learning the history of our people, of Indians. Now, as quoted by Bhaskara II, for solving a quadratic equation by the method of completing the square, okay, he added another method, completing the square, but I think our teacher told us that this portion is deleted in our syllabus. If it is there, we can also cover that, because why not? An Arab mathematician, Al-Khwarizmi, about CE 800, also studied the quadratic equations of different types. Abraham Bar Hia Hanasi, in his book Liber Embadorum, published in Europe in CE 11545, gave complete solutions of different quadratic equations. So in this chapter, you will study quadratic equations and various ways of finding their roots. You will also see some applications of quadratic equations in daily life situations. That is one good way to start a chapter, I must say, but no important points till now. Don't worry about it. Now, one thing for sure, we will not be solving every single question from every single exercises, because if that is the case, then this video will be unbelievably long. We'll do some problems of the same types. Alright, a quadratic equation in the variable x is an equation of the form ax square plus bx plus c is equal to 0, where a, b, c are real numbers and a not equal to 0. Important, because this definition will never be asked, believe me. Definition will never be asked, only the application problems will be asked, and that is the issue part. Because if this definition is not truly understood by you, then the application will definitely never come. Alright, so the general form is ax square plus bx plus c is equal to 0. A, b and c are real numbers and a not equal to 0. If a is 0, then this will be linear. Check. If a is 0, then ax square will not exist, only bx plus c will be there, and that will be 0. Linear equation. Similarly, 2x square minus 3x plus 1 is equal to 0, 4x minus 3x square plus 2 is equal to 0, and 1 minus x square plus 300 are also quadratic equations. Some of you might be asking, well, I can definitely see why it's here, because it's x square in the front, x in the second, and a constant in the middle, and then there is a 0. But here it is an x, then an x square, and then a constant. Okay, the thing is, you can rewrite this one as minus 3x square plus 4x plus 2. Check. Commutative property. And this one you can write it as minus x square plus 1 plus 300. Okay, so that is why these are all quadratic equations. If there is an x square term, there is an x term, and there is a constant, and this is equal to 0, it shall be a quadratic equation in case all these are what? Real numbers, and the coefficient of x square, that is minus 3 in this case, check, is not equal to 0. Okay, now the main focus of these quadratic equations is to have this one, ax square. The rest, if they don't exist, that's not a problem. But this is important, very important. I repeat again, if these are not there, then no problem. But this one is important. It must be there if you want to call anything a quadratic equation. Now you might be asking why? Because we said that a, b and c are real numbers and a is not equal to 0. 0 is a real number. Okay, a and b and c are zeros and a is not equal to 0. That means b and c can be 0. Okay, now let's continue. In fact, any equation of the form px is equal to 0, where px is a polynomial of degree 2, is a quadratic equation. Now let's explain what a degree 2 is. If you check an equation, and here the highest power of a variable is the degree of the variable. Here the highest power is 2, but let's say that I want to add a dx cube. Now what is the power of the equation? 3. Why? Highest power of the variable here is 3. Okay, but in a quadratic equation, as I mentioned before, the degree is 2. Okay, now I hope you understood what the meaning of degree of a polynomial and what is the degree of a quadratic polynomial is, because this is very important for this chapter and I think the rest of the following chapters. Yes. Now, but when we write the terms of px in descending order of their degrees, then we get the standard form of the equation. Okay, it makes sense because check here, descending means highest to the lowest. Highest is 2, so ax square. The next is 1, bx. Then the next is 0. What is anything raised to 0? Anything raised to 0 is 1. Okay, so cx cube will be there, that is c multiplied by 1, that is just c. Okay, understood? And here a is not equal to 0. A is not equal to 0, very important, and a and b and c are belonging to real numbers, this one. And this is called the standard form of a quadratic equation. This is another way of defining what a quadratic equation is, must be learned, very important, can be asked in multiple ways in the exam, mostly for 3 mark questions, 3 mark and 5 mark. I assure you that. Now, quadratic equations arise in several situations in the world around us and in the different fields of mathematics. Okay, so let us consider a few examples. Here are a few examples and we shall be doing the solution here. Okay, now represent the following situations mathematically. So John and Jivanti together have 45 marbles. Both of them lost 5 marbles each. And the product of the number of marbles they have now is 124. We would like to find out how many marbles they started with. Okay. So, let's say that John had X marbles. And since John and Jivanti has 45 marbles, then that means that Jivanti had 45 minus X marbles. Think. Okay. And both of them lost 5 marbles. So at the present they have X minus 5 and 45 minus X minus 5 marbles each. That is X minus 5 marbles and 40 minus X marbles. Understood? Got it? Okay. Now in this case, the product of the number of marbles they have right now is 124. That is x minus 5 multiplied by 40 minus x is 124 as they give it. Multiply all the things here and you will see 45x minus 200 minus x square, and this shall be 124. Check the degree of the polynomial. 2. I mean the degree of this what do I mean? This is in the form, wait, hold on, let's rewrite it like this: minus x square plus 45x. Now bring 124 to the other side and you will get minus 324. Now this is equal to 0. This is in the form of ax square plus bx plus c equal to 0. The value of a is minus 1, b is 45 and c is minus 324. Check. All these are real numbers and a is not equal to 0. I better change my color of this laser. Huh? Yeah, seems better. So basically we have this, what I just, wait, hold on. This was what I just said. Actually I said this, but then they multiplied it with minus 1. If you don't, that's fine. Okay, nothing's gonna stop you. I'll even show you how I got it. So you got minus x square plus 45x minus 324 equal to 0. Now this is 1 unit. Okay, this is 1 unit. So if you multiply minus 1, you need to multiply minus 1 with the entire thing. Just like how our teacher asked us to share the chocolate with the entire class instead of eating it only one. So we got 0 times minus 1 on this side, because whatever you do on this side you need to do that on this side also. Okay, and minus x square multiplied by minus 1, x square, plus 45x multiplied by minus 1, minus 45x, minus 324 multiplied by minus 1, plus 324. 0 multiplied by minus 1, 0. Okay, this is how they got this. Therefore, the number of marbles John had satisfied this equation. Now, the next one. A cottage industry produced a certain number of toys in a day. The cost of production of each toy was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was 750. We would like to find out the number of toys produced on that day. Let the number of toys produced on that day be x. Okay, so if you don't know something, put it as x. Therefore, the cost of production according to our question is 55 minus x. Okay, so the total cost of production in rupees in that day is x multiplied by 55 minus x. Now, why do I say that? Pretty simple. Let's say that you produce 20 things per day. Okay, and the cost of making one of that thing is 35 rupees. You produce 20 things in a day and the cost of making one such thing is 35. Then the total cost of producing all the 20 will be 20 multiplied by 35. Okay, and since the number of toys produced is x and the cost of producing each of them is 55 minus x, the cost of production of all the x toys is x multiplied by 55 minus x, and it is given as 750. Basically, x multiplied by 55 minus x is equal to 750. 55x minus x square is equal to 750. Rearrange that into the correct format. Minus x square plus 55x minus 750 is equal to 0. X square minus 55x plus 750 is 0. Now, here's the thing about board exams. It is filled with injustice. Why? Okay, if you're a low scoring student, then leaving the equation like this or like this might be okay. But if you're getting like good marks in the test, they won't give mark for this, or they will reduce the mark. Always try to write the quadratic equations. If you're scoring low marks or no low marks, I don't know who's seeing this, you must always make it in the correct format. Ax square plus bx plus c. It is more preferable if a here, that is in this case 1, is positive and not negative like this case. It is for that finer getting marks. Okay. Now, therefore, the number of toys produced that day satisfies the quadratic equation, this one. Okay, let's move on. Which is the required representation of the problem mathematically? Now, here, this formula is the required representation of our problem. Example 2, check whether the following are quadratic equations. So we need to check if this are quadratic equations. Now the best way to do, just simplify this. Okay, so x minus 2 the whole square will be x square minus 4x plus 4. Check some videos and identities, because this is a minus b the whole square. Okay, such questions will come, I can assure you that. And this is 2x minus 3. Just simplify. X square minus 6x. Okay, and now this is 5 and 3 comes to the other side to be plus 3. This will be 8 and this is 0. Format of a quadratic equation. Okay, got it? Good. Now the second one however has a twist, or I hope so, or I will be completely fooled. X multiplied by x plus 1, x square plus x plus 8 is here, and now this is equal to x plus 2 into x minus 2. Identity, a plus b into a minus b, and what is that? It is a square minus b square. Okay, and this is x square minus 4. Okay, and now you can simplify this and you will see that x square and x square gets cancelled. Sad. And x plus 12 is there, and x plus 12 is 0. Is the power of this 2? It's not, it's 1. Highest power here is 1. Okay, and it is not in the format of ax square plus bx plus c equal to 0, where a comma b comma c are real. So I am going to represent it like this. You will come to learn about this language if you are taking maths in 11th. And what? A not equal to 0. Okay, but here a is 0. If a is 0, then this term will get cancelled out and we will get this. Got it? So this one, it's not quadratic. Now how do we write this? So if it is correct, if it is in the format of ax square plus bx is equal to ax square plus bx plus c is equal to 0, then actually write it as it is in the form of ax square plus bx plus c is equal to 0, where a comma b comma c are real numbers and a not equal to 0. Now it is not necessary that you write this. If you expand it and write a comma b comma c belongs to real numbers, that's completely fine. Okay, good. Now why did I say that you need to add a comma b comma c belong to real numbers? Oh sorry, a comma b comma c are real numbers and a is not equal to 0. That's because, check this, it is not in the form of ax square plus bx plus c. This is a factual error, because this is actually in the form of ax square plus bx plus c, but just that a is equal to 0, and that's not allowed. Okay, so to become more accurate, you can use this. Now as I said, just simplify the equations and you will get it. There is nothing more on that. A few more things that I have to mention here, however, is to always check identities. This, as you can see, is an identity. Okay, and you must know such identities. You can check that out and perhaps comment that down below, if the comments is on, that is. I don't know how to turn it on. Remark, be careful. In the second above, the equations appear to be quadratic equations, but it is not quadratic equations. Oh yeah, speaking of which, here you see an x into x, you'll see x square. Oh wow, this must be quadratic. That's not quadratic. Why? Because there is an x square on the other side. If there is an x square here, whatever there is, I don't care, and an x square over there, and you add or subtract whatever here, which I don't care either, x square come to this side, it will become minus. So x square minus x square will be 0. That is, there is no term of x square. Okay, that I think I have already mentioned that you must be careful. In 4 above, the given equations appear to be cubic equations, okay, and not quadratic, but it turns out that to be quadratic. As you can see, we often we must simplify the equation before deciding whether or not it is quadratic. Okay, now here we have the exercise questions. The thing is that we have checked some of these questions, so we'll not be checking that. Let's use the word problems. Let's do the word problems. The area of a rectangular plot is 528. Now a few things here. When you're solving max questions, always underline which is important. Okay, the length of the plot in meters is 1 more than twice its breadth. Okay, we need to find the length and breadth of the plot. So there are a few steps, but I'm just going to say that out. Okay, I'm not going to be writing it. Assume that the breadth of the plot is x. Okay, assume that the breadth of the plot is x. That means length is 2x plus 1. Okay, to find the area of length and breadth of the plot, multiply both of them. That is, 2x plus 1 multiplied by x will give you 528. Okay, multiply, you get 2x square plus x, and 528 to this side you will get. Okay, solution to this equation is breadth. Okay, solution to this equation is breadth, and 2 times the solution plus 1 is length. Pretty simple, yeah. Next one. The product of two consecutive positive integers is 306. We need to find the integers. Okay, this also it is very simple. Assuming that the first number is x. Assuming first number is x, that implies that x multiplied by x plus 1. Why did I choose x plus 1? Consecutive integers means one number and the number after that. So if you take a number, let's say 50, the consecutive integer is 51. Okay, examples for two consecutive integers are 27, 28, 13, 14, etc. Now x multiplied by x plus 1 gives us 306. Okay, this can be written as x square plus x. 306 to this side, you will get 306 equal to 0. Now before continuing, I would like to say that from now on I would like to call this the LHS and this the RHS. LHS stands for left hand side and RHS stands for right hand side. Okay, these are the proper designations, don't worry. These sides are called these LHS and RHS, but for the simplicity till now I used this side, but then it's getting confusing, so I'll get to the proper naming. So Rohan's mother is 26 years older than him. Assume Rohan's age is x. That's just simple. The product of their ages in years, 3 years from now will be 360. Ooh, that's old. We would like to find Rohan's present age. So Rohan's age equals x. Rohan's spelling is wrong, right? Rohan's mother's age. Be careful. CBSE is now taking off marks because you might make a spelling mistake or anything like that. So you're not supposed to do what I just did. So x plus 26. Okay. Rohan's age 3 years later equals x plus 3. Rohan's mother's age 3 years later is x plus 26 plus 3, that is x plus 29. Okay, and x plus 3 multiplied by x plus 29 will be 360. Okay, and basically x square plus 29x plus 3x, okay, plus 87 equals 360. X square plus 32x, and now 87 minus 360, so that is 263. No. 273. Yeah, so this is not plus, this is minus 273. Okay, and this is equal to 0 because we took the 360 from the other side. And the solution to this equation will give us Rohit's present age. Next, a train travels a distance of 480 kilometers at a uniform speed. If the speed had been 8 kilometers per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. Look, its speed is x. Okay, and we know that speed multiplied by time is the distance. Okay, so basically the time is 480 divided by x hours. If it is 8 km per hour less, then the speed will be x minus 8. Okay, and it would have taken 3 more hours to complete, means 480 by x plus 3, that is 480 plus 3x whole divided by x, taking LCM. Okay, and you multiply x minus 8 here. Good. So now what do? We do this is equal to 480 plus 6. You could solve this probably, alright, so I'm not going to do that. I hope you know how to take LCM and solve this. Solutions to a quadratic equation. Now consider the quadratic equation 2x square minus 3x plus 1 is equal to 0. If we were to replace x by 1 on the LHS of this equation, we get 2 times 1 square, check y, x is 1, then this multiplication signs here. 2 times 1 square minus 3 times 1 plus 1 equal to 0 equal to RHS of the equation. So we say that 1 is a root of the quadratic equation 2x square minus 3x plus 1 is equal to 0. Why? Because when x is applied, 0 is the solution. This also means that 1 is a 0 of the quadratic polynomial 2x square minus 3x plus 1. What does that mean? If you apply 1 in this quadratic polynomial, then the answer will be 0. Basically, that is the meaning. So in general, a real number alpha is called the root of a quadratic equation ax square plus bx plus c is equal to 0, where a not equal to 0 and a comma b comma c belongs to real numbers if a alpha square, okay, plus b alpha square plus c is equal to 0. We say that x is equal to alpha is a solution of the quadratic equation, or alpha satisfies the quadratic equation. Okay, note that the zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c is equal to 0 are the same. So this important, also important. Okay, now you have observed in chapter 2 that a quadratic, before I continue, one more thing, do not always rely on what I say, also read the textbook while I'm speaking, so that you will have a better understanding of what I'm saying. Sometimes what I say might not be clear and there is no real way that you could express that to me while I'm making this recording, because it's a recording. So please also read what's given here, and if you have any doubts, comment it down below. Okay, now you have observed in chapter 2 that a quadratic polynomial can have at most 2 zeros. So any quadratic equation can have at most 2 roots. What is a root? Root is value for the x, so that the LHS and RHS is correct. Okay, now you have learned in class 9th how to factorize a quadratic polynomial by splitting their middle terms. We shall use this knowledge for finding the roots of a quadratic equation. So let us find the roots of the equation 2x square minus 5x plus 3. So here let us split the middle term 5x as minus 2x and minus 3x. Okay, why? Because minus 2x multiplied by minus 3x is 6x square, and this multiplied by this is also 6x square. Okay, and just what I said here. Okay, and when you add these two, you will get the middle term. Got it? So 2x square minus 5x plus 3 equal, that is our original polynomial, would be equal to 2x square minus 2x plus, minus 3x plus 3, and factorized to taking 2x outside, you will get this, and then taking x minus 1 common. Now this is most confusing for many people. They don't understand how to take out common factors. See, 2 goes in both these and x goes in both these. Okay, so 2x shall be taken outside as common, and you will have x minus 1 here. Okay, understood? And minus 3 is in common in both of these. Take minus 3 and you will get x minus 1. The main goal that you must try to achieve is to get the same number here and here. Okay, I'll explain why. So if you're getting 1 minus x instead of x minus 1, you can also take a minus 1 in common and you will get x minus 1. Okay, why? X minus 1 multiplied by, sorry, cut this. See, x minus 1 multiplied by minus 1 would be what? 1 minus x. Okay, and 1 minus x multiplied by minus 1 would be x plus 1. This is important so that you can get the relations out. Now here if you examine, x minus 1 is common in both of these terms. So take x minus 1 in common, and the rest, that is 2x minus 3, should be put here. Basically, you can rewrite this into 2x minus 3 times x minus 1. So now you can write 2x minus 5x plus 3 is equal to 0 as these. Now the values for which 2x square minus 5x plus 3 is equal to 0 are the same for which 2x minus 3 times x minus 1 is equal to 0. Why? Because 2x minus 3 times x minus 1 is basically 2x square minus 5x plus 3. That's what we factorized till this small one. So either 2x minus 3 is supposed to be 0 or x minus 1 is supposed to be 0. Because if either one of this is 0 here, so if this is 0, then 0 multiplied by this will be 0. And if this is 0, 0 multiplied by this will also be equal to 0. So either 2x minus 1 is equal to 0 or x minus 1 is equal to 0. That means x can be 3 by 2, check, okay, or x can be equal to 1. So 3 by 2 and 1 are the solutions to this equation. In other words, 1 and 3 by 2 are the roots of this equation. Now you can also verify if the roots are correct by applying it in. Okay, so note that we have found the roots of 2x square minus 5x plus 3 by factorizing this into two linear factors and equating each factor for 0. Basically, they are just describing what we just did. Nothing more than that. It's nothing complicated. Now, find the root of the quadratic equation, this one. So, this, I think you'll try that on your own from what we have checked till now. And this one, I will do this because it's kind of difficult. Don't worry. Let's say that we'll do this on our own. Okay, so we got 3x square minus 2 root 6x plus 2 is equal to 0. Check carefully. Okay, what we need to do is divide minus 2 root 6 into two numbers such that the product of their two numbers is 3 multiplied by 2, and if you add them up you will get minus 2 root 6. So any idea on what we can form? I think minus root 6 and minus root 6 works. Why? Minus root 6 multiplied by minus root 6 is 6. Check. Root 6 into root 6, 6. Minus into minus. Okay. So basically these two, when you multiply together, you will get 6, and when you add them together, you will get minus 2 root 6. So 3x square minus root 6x minus root 6x plus 2 will give you 0. Okay. Now here I am taking out root 3x common. Root 3x. So 3 can be broken down into root 3 into root 3. Therefore taking out root 3 will give you root 3 in the inside and an x here. And then if you take out root 3 from minus 6x, you will have minus root 2. Why? Because root 6 is root 3 multiplied by root 2. Okay. Taking out root 3, you will get this one. Now in the next one, I will take root 2 as common. You need to add a plus here. Okay. I'm going to take root 2 as common. So here I have minus root 3 x plus root 2. So here's a difference that you'll see. We have root 3x minus root 2, and here we have minus root 3x plus root 2. Now if you have to do this, if you have to simplify this, take out minus 1. Okay, so basically root 3x times root 3x minus root 2. Taking out minus 1 means this plus will turn into minus. So minus root 2 times root 3x plus root 2. Check all the answers as we are going, because this will be very important. Okay, such a question will definitely come even in the board exams, not just any term or PA test. Now we have root 3x plus root 2, right? Root 3x plus root 2 or minus root 2. Let's check. Minus root 2. So we have root 3x minus root 2 and again root 3x minus root 2. Okay, and this is equal to 0. Always write equal to 0 at the end. If not, the equation will be wrong. So root 3x minus root 2 is equal to 0. Why didn't I write either root 3x minus root 2 is 0 or either root 3x minus root 2 is 0? Because both of them are equal. There is no need for writing it again. And x shall be root 3 by root 2. Now here's the thing. For an additional point, always rationalize the denominator. If you leave like this, it's no problem. But just you might get additional points out of this, or people might check it, because as I told you, board exams are full of injustice. So to rationalize the denominator, multiply this one by root 3 and the numerator by root 3. So you will get root 6 divided by 3. X is root 6 divided by 3. And now don't worry, root 2 by root 3 is the same as root 6 divided by 3. There we go. So as I said, you can leave it like this, but again, if you want further, extra finer points, then rationalize the denominator. So few things to note. You can either write it separately, that the root of this are root 3 and root 3, but since root 3 and root 3 are the same, just say the root of this. What I mean by this is this one is root 2 by root 3, or after rationalizing denominator, root 6 by 3. Okay, got it? and here we have other examples. So that is the one that we got in the first part, okay, and so on. We'll not be solving this because I understand that you know how to solve this. These questions also you can check. It's pretty easy according to what I said, and there's also another method coming up called the quadratic equation, which will prove all of this very hard and pretty much useless later on. Not useless, you must also know how to do these using the splitting the middle term or factorization, because questions may come like this: solve this equation using factorization or splitting the middle term. What do? You take the coefficients of x square and the constant, that is this one, you multiply them. So in this case it is 1 multiplied by 10. This is what? A into c, and I am probably wrong. Why? Because it is a into minus 10. I hope you caught that. And that is a multiplied by c. Pay attention to the class, alright? Because this might be a very difficult topic if you don't understand this. Now we got 1 times minus 10, and this is AC. You're supposed to split B. B is what? Minus 3. You're supposed to split it into two numbers such that, so let's say you got alpha here and beta here. Alpha into beta should be A into C. Okay, so that is alpha into beta should be equal to minus 10. Understood? Great. Others are just simple applications of them. Any doubts, put it in the comments. And now here a special mention. See, we have a denominator of 8 and we hate fractions. We don't like it. So multiply this entire equation by 8, and this side also by 8. Don't forget the 0. It won't matter because it's not gonna make any difference anyway, but still writing it would be good. Now as you can see, this will be 16x square, this is minus 8x, and this is 1. Okay. Another question. Find two numbers whose sum is 27 and product is 182. So let's say one of the number is x, the other number must be 27 minus x. Okay, and if you get the product of this, you will get minus x square plus 27x, and this is equal to 182. That is minus x square plus 27 minus 182 multiply, and this is equal to 0. Multiply both sides with minus 1, you will get x square minus 27x, this is x here, plus 182, and this shall be 0. Okay, you can solve this. Find two consecutive positive integers, sum of whose square is 365. How do we do this? Consecutive positive integers, you can write that as x and x plus 1. So x square plus x plus 1 the whole square will give you 365 according to this equation. Okay, and that is x square plus x square plus 2x plus 1 equal to 365. Okay, that is 2x square plus 2x minus 364 equal to 0. Moreover, you can divide this entire equation by 2 and you will get x square plus x minus 182, and this shall be 0 by 2, which is 0. You can solve this too. The altitude of a right triangle is 7 centimeters less than its base. The hypotenuse is 13 centimeters. Find the other two sides. Now, what is this based on? It is based on the Pythagorean theorem. Let's say this side is A, this side is B, and this side is C. Then C square will be A square plus B square for every right angle triangle. Pythagorean theorem, I hope you know it, because if you don't, you're pretty much cooked in this equation. So we have this question. So we have a right angle triangle here, and its base, let's say, is x, and the altitude is x minus 7 according to what we know, and the hypotenuse is 13. That means 13 square 169 is supposed to be equal to x square plus x minus 7 whole square. 169 is equal to x square plus x square minus 14x plus 49. Simplify this, you can also get it. Now, a cottage industry produces a certain number of pottery articles in a day. It was observed on a particular day that the cost of production of each article was 3 more than twice the number of articles produced on that day. So, let's say x is the number of articles produced on that day, and that means the cost of producing one such is 2x plus 3. Okay, and if the total cost on that day was 90, then the number of articles produced and the cost of each article, multiply this by x, because this is the total number of the total cost of production. Now, I answered a similar question like this before. Hope you were paying attention that time. We got 90 here. Okay, that means we got 2x square plus 3x minus 90 is equal to 0. You can solve this. Okay, so it seems to me there's a little problem. We did a direct jump into the quadratic formula, but no issues, we can continue. I'll make it clear. 4.4 nature of roots. So the equation ax square plus bx plus c is given by x is equal to minus b plus or minus root b square minus 4ac by 2a. Why? Now this is a pretty easy derivation, I will tell you. If I were to say ax, okay, ax plus b by 2 the whole square, using the identity, the proof is not necessary to study, but this is for an extra fact, so that you might use it in class. And this is also the completing the square method. Okay, now ax plus b by 2 the whole square, you can write it as what? Sorry, my bad, I meant root of a x x root a plus b by 2 the whole square. You will get ax square, okay, plus, okay, let's start over again. I made some big mistakes. Let's say we have ax square plus bx plus c here, okay, and this is equal to 0. Divide the entire expression by a. You will get x square plus b by ax plus c by a equal to 0. That means x square plus b by ax equal to minus c by a. Okay, great, we got this. Now if you check, we have an x square, okay, and this kind of looks like in the form of a plus b the whole square thing except for the fact that there is no third term. So let's go ahead and add the third term. Why not? This is the third term. I will explain in a moment why. If you add something here, you must also add the same thing in the other side. We got b square divided by 4a square. Okay, minus c by a. Okay. Now basically what we have right now is x plus b by 2a the whole square. How? Expand this. Okay, you will get x square plus b square by 4a, which is b square by 4a square, which is b by 2a the whole square. Okay, plus 2 times x times b by 2a, that is bx by a. No, wait. So that is x square plus b okay, plus bx by a. Just memorize this for a moment. Just for a moment. We got x square plus bx by a plus b divided by 2a the whole square. Okay, same thing. Just switch the positions here and there. That's fine. Commutative property, but not in division or subtraction. It will mean something else. Now x plus b by 2a the whole square will give us b square by 4a square minus c by a. Now let's find a way to add these. To add these, if you check, a multiplied by 4a will be 4a square, this term. So what I'm going to do, I'm going to multiply the denominator of this one by 4a and also the numerator. I will get x plus b by 2a the whole square will be equal to b square minus 4ac divided by 4a square. Check. Now what I'm going to do is I'm going to take the square root of this. Okay, and I'll get x plus b by 2a will be equal to the plus or minus. It can be both plus and it can be both minus. So you need to check plus or minus what? B square minus 4ac divided by, and you'll get a plus or minus 2a. The best way to represent this is to put the plus or minus here. Okay, and now you'll have the x, taking this to the other side, you'll have minus b by 2a plus or minus root b square minus 4ac by 2a. So basically you can write x is equal to minus b plus or minus root b square minus 4ac by 2a. No requirement to study whatever I just wrote. This is just a derivation for the quadratic formula. So now we know the quadratic formula. Okay, and we know how to apply the things in that. Basically already we know how to apply things, just we just know how to do this. Now if b square minus 4ac is greater than 0, then that means we'll have two distinct real roots and distinct. Okay, but in case b square minus 4ac is equal to 0, then that means the roots of the equation are both equal, but again it is real. Okay, therefore we say that the quadratic equation ax square plus bx plus c has two equal real roots in this case when b square minus 4ac is 0. If b square minus 4ac is lesser than 0, then there is no real 0 whose square is b square minus 4ac. Okay, so therefore there are no real roots for the given quadratic equation if b square minus 4ac is lesser than 0. If b square minus 4ac greater than 0, the roots real, distinct. If b square minus 4ac equal to 0, roots real, equal. If b square minus 4ac lesser than 0, no real roots. There we go. Now, since b square minus 4ac determines whether the quadratic equation has real roots or not, and if it is equal or not, then b square minus 4ac is called the discriminant of this quadratic equation. So a quadratic equation ax square plus bx plus c equal to 0 has two distinct real roots if b square minus 4ac greater than 0, two equal roots if b square minus 4ac is equal to 0, and no real roots if b square minus 4ac is less than 0. So here are a few questions that from which we studied till now. I'm sure that you can all answer because it's quite easy. Okay, check these examples. I'll just show you here. Find the discriminant of the quadratic equation, this one, and hence the nature of its roots. A pole has to be, pause and do it. A pole has to be erected at a point on the boundary of a circular path of a diameter 13 centimeters in such a way that the differences of its distances from the two diametrically opposite fixed gates A and B on the boundary is 7 meters. Is it possible to do so? If yes, what is the distance from the gates? What distance from the gates should the poles be erected? Okay, and now what? Example 9, find the discriminant of the equation 3x square minus 2x plus 1 by 3 is equal to 0, and hence find the nature of its root and find if they are real. Find them, the roots, if they are real, using the quadratic equation. We have the exercises also. I'm speed running through the chapter, so I'm not checking all these. Okay, so that's over actually. Okay, so let's also check the summary. In this chapter you have studied the following points. So a quadratic equation in the variable x is of the form ax square plus bx plus c, where a, b and c are real and a not equal to 0. Okay, a real number alpha is said to be the root of a quadratic equation ax square plus bx plus c is equal to 0 if a alpha square plus b alpha plus c is equal to 0. The zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c is equal to 0 are the same. So minus b by a is still the sum of the roots, and c by a is still the product of the roots. If we can factorize ax square plus bx plus c, a not equal to 0, a, b and c are real numbers, into products of two linear factors, then the roots of the quadratic equation ax square plus bx plus c is equal to 0 can be formed by equating each factor to 0. Okay, quadratic formula, the roots of the quadratic equation ax square plus bx plus c is equal to 0 are given by this formula. We derived this, we saw how it works, we saw what is the importance of b square minus 4ac. So I hope you still recall it. A quadratic equation ax square plus bx plus c equal to 0 has two distinct real roots if b square minus 4ac is greater than 0, two equal roots if b square minus 4ac is equal to 0, and no real roots if b square minus 4ac less than 0. Now, before I conclude, I would like to ask you two questions, a 1 mark question and maybe a 5 mark question. Okay, so here we have it. Um, what is oh I need to okay. What is b square minus 4ac called? Okay, what is that name? Okay, and then we got another big question. uh, it will be easy. It's a word problem. So here's the thing about word problem. The best advice I have ever got, and I'm going to give you right now, of word problems is that uh, people see word problems as like boring max and things like that. If you want if you want to solve such word problems, then the thing that you just have to do is to visualize these problems. Think that it is a problem that you are facing right now. Like for example, the area of the what prayer hall, the first example that we saw in this chapter. Imagine you're the, I don't know, architect, engineer, whatever, and you're making that thing. Okay, and you need to find this out. uh, then then you try to understand what are given to us and what we can manipulate out of what is given. Be the architect, be the main character, and you'll get it. That's the thing about word problems, mostly. So here's a word problem that you need to solve. And the next problem is, a farmer has a rectangular field with an area of 240 square meters. He wants to increase the length by 4 centimeters and decrease the width by 2 centimeters. But after doing so, the area of the field remains the same. Okay, now form a quadratic equation to represent this situation. Okay, determine the original dimensions of the field. Analyze how the area remains unchanged despite the dimension changes. Now, the thing that you could do right now is to try to answer them. If you don't, that's fine. In the next max video, I will be sure to complete this problem and then continue. And try to do this problem and comment it down below. And if you don't, just at least try to do it. All right, that will be very good, because I have seen such problems in the previous year board exam papers. So just don't miss out. So thanks for watching and bye.